Good afternoon, guys. Good afternoon. Just checking that you can hear me. All right, good. You can now see the screen.
Afternoon, sir.
All right, good. All right, so the topic for today is, as you can see on the screen, the locus. There's a topic that really comes under the coordinate geometry section of the syllabus, right? And it's quite frequent on exam papers, but it's not all, you're not going to see a long whole question on it. So it usually comes as part of a question. So you might get a coordinate geometry question, and it might be part of it. Like if you get an equation of circles question, it might be part of it. Like a last part for 4 marks or 3 marks. So you usually set them quite simple on the exam paper. I've seen people going into exam and get a locus question and come out of the exam and say, what is locus? What is locus? And it's clearly there on the syllabus. A very easy topic. And it generally apply some most times it's some coordinate geometry you're doing. But it's like you're doing coordinate geometry on a point, XY, under some rule. And they're going to describe that rule to you, some limitations. So it's like you have a point XY that the position of that point XY is restricted by some rule, some conditions that they tell you. And it's a matter of you applying those conditions and establishing a relationship between X and Y. That relationship between X and Y comes in the form of an equation, a Cartesian equation, like one of your normal equations, right? When you basically apply that rule on the point and you get that Cartesian equation, that equation is for some curve, whether a curve or some line. The curve that connects the X and the Y, that basically defines how that point or the possible locations of that point. So the possible location of that point that follows that rule might be on a curve or it might be on a line. That curve on that line is called the locus, and the equation is called the locus of the point. All right? So in a nutshell, what I've just said, that's what it is. So for example, they might tell you that a point P, and you always give the point coordinates XY, whether they give it to you or not. A point P moves such that it is a fixed distance of 2 units. This is one of the more common examples. But a point P is a set distance, like 2 units from some point, and I give you some other point A, for example, 3, 4. So if a point P moves such that its distance from a fixed point 2, 4 is always 2 units, then it means that P is moving on a circle. Right? So it means that let me shift these up. It means that it's like you have the point A here, and P is moving such that its distance from it is always 2 units. So P is here. It's always 2 units. And so P therefore can be at any point on that circle. And so the equation of this circle is the locus of P. Because P can be anywhere on this circle, any point on this circle, right? You will be 2 units from that point. And so the locus of P becomes the equation of this circle. The equation of this circle will be x minus 3 squared, which is the x part at the center, plus y minus 4 squared, that's y at the center, equals the radius squared, and the radius will be 2. And so this will be the equation of that locus, because it will basically be the equation of this curve that the locus is moving on, the point is moving on. right? So at the locus, the curve is the locus of the point. The path that the point can be on, and then the curve that the point can be on, and the line that the curve can be on. It's called the locus. Right? And it's basically us, it's basically us following instructions, call the point P, and put it under some coordinate geometry concepts, whether it be distance or gradient or length or some coordinate geometry concept, and establish a relationship between x and y. Right? So I have some notes on the screen here. I got out of a book. It basically says what it is. It's right here, defining what a locus is. And loci is a plural of a locus. If we read this, we can see a kind of a explanation or a definition. It says, in general, within a plane, a point can be anywhere. And furthermore, if xy are the coordinates of the point P, then xy can take any value independent of each other, independently of each other. In other words, you can place a point anywhere on a graph. So if you have a graph, a point can be anywhere on that graph. That's what they're basically saying there. What if you define a specific rule or specific conditions under which the point has to be? That's what the second paragraph is going to say, right here. The second paragraph now is going to tell us about that. It says, however, when the possible position of that point P are restricted by some condition to a line which is either curved or straight, in other words, a curved line or a straight line, the set of points satisfying this condition is called the locus of the point. So the set of points that satisfies the condition that they are putting the restrictive conditions, right? That set of points is called the locus. And that set of points oftentimes fall on a curve or on a line that you can write as an equation. That's what this other part is saying. It says, further, the relationship between x and y, which applies only to the locus of P, defines that locus. It defines that locus. So the relationship between x and y, right? The relationship between x and y, basically the equation connecting x and y. When that equation applies only to the locus of P, in other words, the locus of P, remember, is a set of points that P can be on, right? When it defines that locus, right? That relationship that defines that locus is called the Cartesian equation. So when you get a relationship connecting x and y, you have found the Cartesian equation of P, and it is also called the locus of P. So in other words, a lot of the times the question asks for the locus of P, you're trying to find the Cartesian equation of P, an equation connecting the x and the y. That's all I have to say about that. Just a matter of doing examples now. Right? It's not much to it. And there are examples on the screen. Like for example, this one. It says a point P, remember, always call a point XY, guys. A point P, call it XY. You call it XY. Trying to get a relationship between X and Y, following the restriction that they gave us. Is restricted. It is restricted so that it is equidistant from this point and from this point. So P moves such that it is equidistant from those 2 points. And sometimes you can figure it out, you know. So if you have a point A and a point B, I have a point P moving so that it is the same distance between them at all times. And it is here, 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 here. This would be equidistance from them. Here will be equidistance from them. Here will be equidistance from them. Can also be on this side. So basically, any point on this line, which is now the perpendicular bisector, would be a point where P can be on. P can be on anywhere on this point. So we get the equation of this perpendicular bisector. That would be the locus of P. But to calculate it, calculate this equation, all we have to basically do is call the point P, xy, and say, calculate that, make a relationship, xy, make a relationship that says this distance, get an expression for that distance, and put it equal to an expression for this distance. And you put this distance AP equal this distance. So we'll just set up a relationship that where AP is equal to BP. I use coordinate geometry to get the expression for AP, expression for BP. You equate them, and they simplify it as far down as you can, and you will get the equation of this line. You will get the equation of that line, right? And that is what is done in this custom over here. So what they have basically said, P is restricted so that its position is where PA equals PB. PA equals PB. All right. So and I actually show it on this graph, this sketch right here. So they put P randomly there. And so this distance and this distance is the same. That distance and this distance is the same. P is going to be on this line down here. So. All right. So how you proceed now? You get an if PA equals PB, because I know length of the line formula has some square root business in it. What I tend to do sometimes is square it. But if I did not put the square here, then I would have a square root on this. If I did not put the square here, then I would have the square root on this. And then this would be an expression for PA, and this would be an expression for PB, using the length of line formula. Remember, I'm using P as a point xy. A is a point 1, 2. And B is a point -2, -1. So this is a formula. This becomes expression for PA because it is x minus 1 squared, see there? And y minus 2 squared, see there? Under the square root sign. And then over here now, it will be, over here now, you're doing this between this one and B now, right? So it will be x minus a -2 gives you x plus 2 squared. And y minus a -1 gives you y plus 1 squared. And so you're now equating this and this. But what I've done in this example is just to square both sides, because if this equals this, then it means that the square of this is also equal to the square of that. And that's what I've done here. See there? And so if I remove the square root, and this equals this, it therefore means that this expression is equal to that expression. And that's what they have right here now. This equals that. And if you simplify this all the way down, it's going to come right down and give you that equation, which would be the equation of the line right through here. There you go. Right through here. And pass through the origin. That line. That's a better line. And if you notice, that's what they have said. It said it reduces to this, x plus y equals 0, right? So note that the line x plus y equals 0 is the perpendicular bisector of AB, as I've said. But understand that so far? Better go with that?
Yes, yes.
It's quite simple. Just a matter now of doing examples and how we implant the various conditions that they will put us on. And oftentimes, it is useful to make a little sketch, as they have done here. Make a little sketch. Put on what you know. What you don't know, the point that you know, you always call it xy. Call the point P xy, and you proceed. Right? You're using the condition that they tell you to establish an equation to connect x and y. When you get that equation connecting x and y, that is a locus. That's another example here. So these examples down there, I'm going to do them on the screen, all of them. And then I'm going to do some past papers. So this is supposed to be a really short class. That is a really short topic. But it is exclusively pure maths. It's not an advanced at all. All right? But here now, look at this one. And this is a sketch they give for it. Eh? Always give a sketch. So this one says, the point P, say they're calling it XY for us now. Sometimes they don't call it XY, they just give a point P, but you must always call it XY. The point P is twice as far from this point as it is from the line x equals 5. Remember, the distance from a line is always a perpendicular distance. So when I say the distance from a line, they're talking a perpendicular distance. Bear that in mind, right? Perpendicular distance. They will not say perpendicular distance, they will just say distance. So the point P is twice as far from here as it is from this line. So in other words, it is further from here than it is from the line. Twice as much. All right. So this is a sketch right here that they give. So they put in the line this is the line x equals 5 right there. So this they didn't mark it x equals 5, but this should be the line x equals 5, or to zoom it up. This is the line x equals 5. So it means that the x coordinate right here says 5. Right here, the x coordinate is 5. And then this is the point A, which is 3, 0. And what they're saying is now that this distance is twice this one. So this distance is equal to 2 times this one. Note that this point, it would have the same y value as this. All right? So this point will be the point 5y. So what is this length? This length would simply be 5 minus x. And the y value is the same. And then this length, now you're going to get an equation for that length using these 2 points. And then you just put what they have said, put it on the condition that they have said. You see it over here now, look at it. Look at it. So what they have said is the restriction of P is such that PA is 2 times PN. The distance from A is twice the distance from N. What is the distance PN? PN is going to be 5 minus x. Remember, the x coordinate here is x and the x coordinate here is 5. So this length becomes 5 minus x. Right? That's what I have right here, 5 minus x. And then now what is this length? What is this length? PA. Same square root business. Square root, and you do the difference in y, the difference in x squared for those 2 points. But what they've done again to eliminate the square root business is to just square this thing. They just square this and square this side. And so they end up with this. By so doing, we don't have to put the square, but when I do it, I'm going to be using my square root. I'm not necessarily going to be squaring them. But that's what they have done here. So then now, the PA squared, if I did not put on the square again right here, but if I did not put the square, it will be the square root of this. That will be the distance between these 2 points. Between here and here, this length. Right? Distance between this point and this point will be this. This length will be that. If I did not put on the square, it will be the square root of the difference in, well, put the difference in y squared first, which is y minus 0. That's where I get the y squared. And then they put x minus 3. See? X minus 3 squared. And then as I said, no, this length Pn is 5 minus x. And what they have done here, if I did not square it, it would be that. And in my example, I would equate this thing to this. I don't have to square both sides anyway. Right? But that becomes the well, equated to twice that, to 2 times this, to 2 times this, because you plug in that there. All right. And then when you solve and reduce it, end up getting this as a locus. That becomes a locus. It works out itself. All right. So best thing to do now is just run these examples down here for you. All right. And best thing to do, run these examples down here. I mean, this is one of those topics where It's like, it's easier to understand when you see the examples done. You have some topics like that, explaining it and all of that, but it's just easier to understand when I do the examples. So I'm going to do these examples down here from 1 to 7. And after that, I'm going to do some past papers. I'm going to see that the past papers are even simpler than some of these. All right, so I'm going to do the questions over on the right side of the screen. All right, so let's go. But all right so far? But okay so far?
Yes, sir.
I want you to screenshot this thing because I wanted to redo the questions. All right, I wanted to screenshot these questions. I wanted to redo them. I want to do them, but I wanted to do them over by yourself. All these questions right here. And when I put up the past paper questions, I wanted to screenshot them and do them again as well. Right, that is the whole idea. I'm doing them for you first, but you need to be able to do them for yourself. All right, you need to be able to absolutely do them for yourself. It's a very easy topic, and it features quite frequently on the exam paper. So you're not gonna escape it. Hold on a second. You're not gonna escape it. All right. All right, let's look at this first one. Just that one. Right here. So in all cases, we have to find the Cartesian equation of the locus of the set of points P in each case down here. So we'll find the locus of P. When we find the locus of P, we will find the Cartesian equation connecting X and Y. Remember, in all cases, we want to use P as a point XY. Or trying to establish a relationship between X and Y. We'll get that equation connecting X and Y, that is the locus of P. All right? So just bear that in mind. All right, so the first question here. First question here basically is saying P is equidistant from P is equidistant. I'm going to mark it like this. Doing this first question. P is equidistant from this point and this line. All you need to do is make a sketch of it. Make a sketch so you can see what they are saying. Equidistant. So my sketch would be that I would set up my y-axis and my x-axis, set up like this. I'll put in my line x equal -2, this line. Put it over here. And I know this line x equal -2. And then this point 4,1, I'll put it over here. 4,1 will maybe be right here. Let's put on that point. Let's put on that point in black, 4,1. So let's put on a point P right here. I'm gonna call it something. Let's call it A. So we can reference it. So A is a point 4,1. Bring it a little closer. Call this point A. This is 4,1. That's a point 4,1. And then I'm going to put the point P right here. Let's put the point P right here. And I give it coordinates x, y. And it's, what the question is saying is that this distance is equal to this perpendicular distance. So the question is basically saying. So I'm going to mark, let's say this distance and this distance is the same. Then let's say I call this point right here, so B, where it meets this line, B. What will be the coordinates of B? It's the same y coordinate as that. So B will be the point. Remember, this is -2, you know. Right here is -2. So at B, the x value is -2 and the y value is y. But it has the same horizontal line as that point. Right? Because remember, the distance from a vertical line is a horizontal line. It's on a horizontal line. So this point B, it will be -2y. And you go on clear now, because all you're going to be saying now is that AP is equal to BP. And you equate them. That's all you have to do. Based on what they said for the question, AP is equal to BP. The locus is such that AP is equal to BP. Right? This is my y-axis. And this is my x-axis. So I've made a sketch of what they have said. So I'm going to just say now, AP is equal to BP. And when I set up that and solve it and simplify it, I will have my locus. What's the expression for AP? AP is the length of this line. The square root business become the square root, but this is 4, 1, and I'm going to zoom this up. Right here says 4, 1. Right, this is 4, 1. Let's not forget, this is 4, 1. All right. Ready now. So what is AP? AP is the length of this line. Becomes the square root. Difference in the x value squared. That is this x value minus this x value. So it's x minus 4 squared. Plus difference in the y values. That's this y value minus this y value. So it's y minus 1 squared. That distance is equal to BP. You want BP simply now. BP is the length of this horizontal line, which is basically the difference between this x value and this x value. So it's like you go 2 this way and then you add x to it. So it's 2 plus x. 2 plus x. 2 carry back to the y-axis and then you add x over there. Based on that. So it's 2 plus x. Based on where I put my coordinate xy. I always put the xy in the positive quadrant, right? That's a safe way to put the xy. Put it in the positive quadrant. May you work in these questions now. Simpler, less confusing. Put it in your positive quadrant. All right? Put it in the positive quadrant and work it. So the BP expression would just be x plus 2 or 2 plus x. 2 from here, we got 2 to here, and then we go x more to reach a point horizontally. That's along this line, this distance. Here is 2, here is x, 2 plus x. So that distance is 2 plus x. That's BP. It's 2 plus x. So far, so good? So far, so good, guys?
Yes, sir.
Then we're going to square both. We're going to solve this now. We'll square both sides. We'll square this side. I'm going to square both sides and let's expand this under here. Let me square both sides first. So we get x minus 4 squared plus y minus 1 squared equals 2 plus x squared. Let me expand and simplify, and I get my locus. Expand and simplify. When I expand this first, I'm going to get x squared minus 8x plus 16. When I expand this, I'm going to get y squared minus 2y plus 1 equals, when I expand this, I'm going to get 4 plus 4x plus x squared. Then I'm simplifying now. Let's transpose everything over this side. So this x squared eliminate that x squared. So the x squared again gone. This is the only y squared term in there. I'm going to write it down first. Y squared. Then the y value in there is this is the only y value in there. That's minus 2y. In terms of the x values now, this x value, the x squared gone, right? X squared eliminate x squared. And this x now come over here and minus 8x. So minus 8x and minus 4x is minus 12x. I'm getting minus 12x. Minus 12x. And in terms of the numbers now, ready now, so this and this makes 17. And I'm going to subtract this 4. 17 minus 4 is 13 equals 0. That is my locus. This is my answer right here. Done. Once you can get this, and you get it from a sketch, the sketch helps. So you have to practice to do a sketch. When you do a sketch, you see what is happening, it becomes very easy. But good at that? But okay with that?
Yes, sir.
All right, that finishes number 1, guys. Let's look at number 2. Number 2 right here. Again, you want to just do a sketch of what they have said. A lot easier and you do a sketch of what they have said. All right, let's see what they say. They say this is a typical easy question. It says P is equidistant from here and from here. P is equidistant from those 2 points. So again, I can sketch it. Can just sketch it. Just put on a sketch. So it's like I have my y-axis and I have my x-axis. So 3, 5 would maybe be up here. Let's call that point A, 3, 5. And this point, negative 1, 1 will be somewhere over here, like maybe here. Let's call that B, negative 1, 1. And then now, P is maybe here. I just go and put it here, P, and call it XY. And I know that this distance and this distance, they don't look like that one. Maybe carry this over some more. It look more realistic. So maybe this distance, sorry. Is the same as this distance. So all I need to do is get an expression for this distance, get an expression for that distance, and equate them and solve. Equidistant. This is an easy one. You know? This is a typical one. A point is equidistant from the 2 points. In that case, you don't even need a sketch. Just know that this distance equal this distance, that distance, and you equate them. So when I say AP equals BP, that's a locus. The locus is such that AP equals BP. What's an expression for AP? Length of line formula, square root. Difference in x squared, x minus 3. X minus 3 squared. Plus difference in y squared, y minus 5. Y minus 5 squared. Equals, and this length now, BP, this is between these 2 points, BP, square root, difference in x value squared, x minus a negative 1, that's x plus 1, x plus 1 squared, plus difference in the y values, y minus 1, y minus 1 squared. That's what they're solving. First thing you're going to do is square both sides. If I square both sides from here, then I would not need the square roots. And I would just have that. So you can approach it this way as well. This is length on both sides. Just leave out the square by square on both sides. So AP equals BP. This means that AP squared equals BP squared. And so you can leave out the square here and leave out the square here. That becomes a locus. You just need to expand it, simplify and solve. Solve after the now. Right? And what you're gonna get really is that you're on a perpendicular bisector between the 2 lines. And the line down here. That's the line that you're gonna get in. Right? But to follow through on the process, expand this, you're gonna get x squared minus 6x plus 9. Expand this, you're gonna get y squared minus 10y plus 25 equals, expand this, you're gonna get x squared plus 2x plus 1. Expand this, we're gonna get plus y squared minus 2y plus 1. All right, and then we're gonna go and say this x squared cancel this x squared, this y squared cancel this y squared. Okay, I only supposed to get that line, a perpendicular bisector. Let's transpose everything over onto the left side. All right, so look at the x values first. This is minus 6, and this is 2. So you're gonna get minus 8x. Look at the x values. When you bring this over here, you're gonna get minus 8x. You look at the y values now. This is minus 10y. This is minus 2y. This one come up plus 2y. So I'm gonna get minus 8y again. I'm gonna get minus 8y. Look at the numbers now. Well, this one, this is 2. All right, then that is 2. and this is 9 and 25 is 34. I'm going to subtract the 2 over here. 34 minus 2 is 32. So we're going to get plus 32 equals 0. Right? And then you can divide through by 8. Right? And divide through by 8. If you divide through by 8, or to make these positive, we can divide through by negative 8. So we can divide by negative 8. And so this becomes x, and this becomes plus y, and this becomes minus 4. Minus 4 equals 0. This is a locus. That's the answer right there. There's something I forgot to show you though, which is a formula for when you want to find the distance of a point from a line. All right? Distance from a point to a line. A line with an equation that you know. Think of it on the slide here somewhere. See it here? This thing. Right. Right. This is the formula. Now, I've not seen an exam question where it has to be used. So look here, if I have an equation in this form, look at it carefully. Ax plus by plus c equals 0. The equation of the line must be in that form. I want the distance from a point to that line. This becomes it. And if you notice, it's plus or minus, because the point can be on either side of the line. Right? So this is the expression for the distance. If they tell you the distance is 2, it means that this thing will be plus or minus 2. Right? Plus or minus 2. So I've not seen any pure maths question yet where you have to use this formula. I'm not seeing it, but look at it carefully. So I have an example on the screen as well. So if we want to find, for example, the distance from this point to this line, like you're setting up this expression where you're dropping this on the x and dropping this on the y, and doing the square root under here of this value squared plus this value squared. So it's almost like you're writing back the equation of the line, you know. It's almost like you're writing back the equation of the line. This. You're writing it back here, on top there. But you're dropping the coordinates of the point on the x and on the y. And you're dividing that now by the square root of these coefficients. Squared. That becomes the length, the distance from a point to the line. So in this example, the distance from this to this line becomes this. I say no, it's plus or minus. If you have a line, the distance is plus or minus. So if you have a point here, it's either plus or minus. So it's either about
that's the formula we should just go.
This is the formula, yeah. This is the formula to do it. For any point. Look, notice you drop the coordinate, it's like you write back the equation here. Where you drop the coordinates of the point for the x and for the y when you write it back here. So you put back the equation here, you put the equation on here, but you're putting the coordinates for the x and the y here. And then you're doing the square root of this value squared plus this value squared under there. Let's look at it carefully, this formula. This is an example. So why we have plus or minus? Because you don't know which side of the line is plus or which side of the line is minus. That is why. That's why we have plus or minus. I don't know which side of the line is plus or which side of the line is minus. And if you're talking about a locus, let's say they give you a line. I want the locus of the point that is 2 units from the line. They mean that on this side the point could be 2 units, and on this side could still be 2 units. On this side. So to account for the point being on either side, we could put the plus or the minus. It will work out itself. And so that will cause it to get 2 lines, one up here and one up here. 2 lines. All right? In this example. It's another example here. It's an example here. It said the point xy, so this is a locus now, moves such that its distance from this line is always 7. Is always 7. So plus or minus the formula for the distance. So look again, is that they take the equation, or the expression on the equation, when we put it equals 0, and drop it onto here. But the point is xy. So it means that this x come in here and this y come in here. Because not like you have a point now, like 2, 3, you know. We can drop the 2 here and drop the 3 here. You know? The point is a general point, a locus point, xy. So it basically putting back the expression for the equation and there now. And you're dividing that now by the square root of this value squared plus this value squared. And then say it is 7. So put 7. Instead of putting them plus or minus over here, we could have put the plus or minus on this side instead. Same difference. But that becomes a locus. Because the plus or minus, as I said, is for the fact that it can be on either side of the line. And then what we know is that when you expand out this, and the one with the plus and one with the minus, you're gonna get 2 lines. Because if you have a line running like so, and you want the locus of points that are equidistant, you're gonna get one on this side and one on this side. This is 7. And this one is also 7. And so that's why you're getting 2 lines, one with the plus and one with the minus. Alright? That's what is happening here. So you have to remember this formula, guys. Screenshot it. In fact, you have to remember the whole of this. And it's also good to screenshot this example with the numbers. So you see how the numbers use this example. But our locus question will go is that they would tell you that the distance is 7 or 5 or 11 or something. But as I said, I've never seen a question where you have to use this formula in pure maths. But I'm still giving it to you. The popular formula for locus questions, this formula right here, from back in the day. I don't know about 60, no, but back in the day, we had to use this formula. We had to know it and use it. We had to know it and use it. Because a lot of the questions were for distance from those kind of lines. When the distance from a vertical line or distance from a horizontal line, it's easy. But distance from a line like this, you want to use this formula. All right? You want to use that formula. So screenshot this for me. Screenshot this with the example and use it. And then this is a good example now to screenshot as well right here. This one. With the locus. But I've not seen any question in pure maths yet where we had to use this formula. All right, so I could continue with the question that we're on. So this number 2 a while ago. Let's jump on to number 3 now. Number 3, which is here. It says P is 3 times as far from the line x equals 8 as it is from this point, 2, 0. So again, you want to sketch it. It's 3 times as far from that point, from that line, as it is from the point 2, 0. So you want to sketch this information, this one. Sketch it and then you write the locus distance. All right, let's sketch it and you call the point PXY and you proceed. All right, so I'm going to sketch it like this now. All right, ready. So let's say I'm going to put, let's put an axis in black. Let's say this is my y-axis and this is my x-axis. All right, everything is in my positive quadrant. 2, 0 is in the positive quadrant. X equals 8 is also in the positive quadrant. So I'm putting that line x equals 8 first. Let's put down in red over here. So then x equals 8. I'm also going to put on the point 2, 0 down here. So this is point 2, 0. I'm going to call it A. 2, 0. All right. Now they said the distance from the line is 3 times. 3 times as far from the line as it is from the point. So it means that the locus is closer to the point. So that the locus is like the point is here. P. And P is xy. And the distance from here. This distance is longer by 3 times. So I'm going to put 3 lines on this to say it is 3 times as long as that. So it simply means then that this length is equal to 3 times this length. Call this point here, so B. Let's call this point B. What will the coordinates of B be? They're going to have the same y coordinate as that, but the x coordinate of this point is 8. So it means that B is the point 8y. Putting the coordinates of this point is very important, you know, guys. Of this point right here, very important. Right? And then this is perpendicular. All I need to say now is that this length is 3 times this length. So 3 times the length are equal to the length there. Because this is longer. This is what they've said. This is what they've said. Right? So it simply means that BP is 3 times AP. This is what they've said. So I'm going to set it up. BP is 3 times AP. That's what the question said. But understand that?
Yes.
And maybe this guy was working that out. I can square them if I want to, but I can work with them like this. I can square them and leave out the square root when I write the formula. Right? So I can square them and write BP squared becomes 9 times AP squared. Right? Now BP is a horizontal line, so the distance on BP I'm gonna write down in red. I write down in purple. Yeah, put down in red. This distance right here, so it's very easy. This is just 8 minus x from that length. Horizontal length is 8 minus x. Because the x coordinate right here, so is 8, right here, so it's 8. And right here, so is x. So this length is 8 minus x. Easy. So I'm going to write 8 minus x right here, so as that length. And then this length, we're going to get the normal distance of a line formula. All right, so see here now, the BP is 8 minus x. I'm going to square it. The BP is just 8 minus x. I'm going to write 8 minus x squared equals 9 times. And the square means that we're now going to put on the square root. We're now going to put on the square root on the length of the line between these two. I'm just going to write it. So we come the difference in the x value square, which is x minus 2 squared. X minus 2 squared plus y minus 0 squared, which is usually just y squared. That's a locus. Let's see to simplify it now. I'm done. That's a locus. I just need to simplify that now. And I'm good. So expand this side. I get 64 minus 16x plus x squared equals, I'm going to put, when I expand this, I multiply it by 9. Let's expand this first. X squared times 9 is 9x squared. I'm going to get 4x as my middle term. Minus 4x times 9 is minus 36x. I'm going to get 2 squared is 4. 4 times 9 is 36. I'm going to get 36. I'm going to get 9 times y squared is 9y squared. That's what I need to simplify now. Simplify that now, I'm done. All right. Put everything on one side. All right, let's say we carry everything over this side. So I'm gonna leave, all right, this 36 come over here and subtract from the 64. 64 minus 36 is 28. I'm gonna get 28 over here equals, this come over here and subtract from this 9x will give me 8x squared. In terms of the x now, this minus 16 come over here add to this, gonna give me minus 20. Minus 38 plus 16 is minus 20, so minus 20x. And then I still have this 9y squared by itself. basically that is it. Right? And that's it. That is it then. That is it. That is the equation right here. Can rearrange it and write it as 8x squared plus 9y squared minus this 20 equals 28. Can write it like that. Not 20, 20x. That becomes the equation of the locus. As the equation of a circle, you know. No, right. It's an ellipse. It's an ellipse. That's an ellipse. Let's not worry about that. That is the locus too. Understand that, guys? Understand that?
Sir, could you have done it the other way?
Which other way?
When you're trying to find the equation of the length of a line, and you have the square root.
Yeah, because all that would happen if I did not square this first, and I'm working with this, all that would happen is that I would not have any square on this. I'd have a 3 right here, and I'd have a square root over this. That's all. Because BP would still be 8 minus x up here, so this is 3 times this length. So if I square both sides now, I'm still going to get this expression. Understand? Understand me?
Yes, sir. Yes.
This with the square. Well, this with the square are not same difference. You're going to get the same answer. Alright? Alright, so that finishes that one. Let's go to the next one. Let's look at the next one over here. Number 4. Number 4 says P is equidistant from this line and from this line. So here now, this is an example of using the length of the line formula. This is an example you have to use the formula that I just showed you. And if you notice, they give the two equations in that format. Equals 0, equals 0. So P moves such that the same distance from this and from that. Alright? So what will be our sketch? So we're not sketching vertical and horizontal lines anymore now, right? If you look at it critically, this one would have a negative gradient if we transpose the x over here. And this one we transpose the y over here to a positive gradient. So one is a positive gradient, one is a negative gradient. So it is like you have these two lines now. One so with a positive and one with a negative, right? Two lines must meet, because they're not parallel. So they must have an intersection point. Right? And then now the point is moving such that it is the same distance from the two lines. So that the point is here. It is xy. And the perpendicular distance to here is equal to the perpendicular distance to there. So so the point is going to move like that. So the point is going to move, That is how it's going to move. But you can also get two lines. There's another way it can move. Because let me show you why it's another way it could move. Because it could be that the lines, if you extend the line down here and down here, then the point could be over here instead. Show you why it's two lines are going to get. The point could be here. So that this distance and this distance equal. So the point can also, it's still between the same two lines, So the point can also move this way. So that that line or this line, the point will move on. That's where the positive and negative come in. There's actually two lines that possibly can get. Alright, but we're just going to work it for one and to work out itself. So we're going to work it as if it is just this. And to work out itself. That's why I put in the plus or the minus to account for the fact that it can be two lines. right? Two sides. That's why they put in the plus or the minus. But the p can be on either side, right? So I'm gonna call this one equation 1, and this is equation 2. Equation 1 is the first line, right? This one, 3x, sorry, 3x plus 4y plus 5 equals 0. And line 2 is the other one, which is 12x minus 5y plus 13 equals 0. And I don't know if you notice, you have the Pythagorean triple values here, 3, 4, 5. Also, you have the Pythagorean triple values here, 5, 12, 13. And that is for us to get some easy elimination. All right? So the distance of P from this line is the same distance it is from this line. All right? That's what it is. Let's say that the distance that it is from this line. Let's call that distance AP. Let's put this point here as A, just to reference it. And put this point here as B. So this A represents all points on this line, and this B represents all points on this line. And basically what we're saying is that this distance and this distance is the same. These two distances equal. All right? So the distance of this point from this line, which we're going to use as PA or AP, is equal to this distance on this side, which is BP. But remember, you have to put in a plus or minus in there to account for the fact that it can be on either side. So what will be the distance of this point from this line? Remember, like I put the equation back. So like I put the equation back, so it becomes 3x plus 4y plus 5 over the square root of this squared and this squared. 3 squared plus 4 squared. That's this distance we just work out, you know. Is equal to, I'm going to put a plus or minus over here for this distance. You don't need to put on one side. And then this distance is from this point to this line. So again, it's like, when I put in a box, it's like I put back the equation. This was equal to 0. And it becomes 12x minus 5y plus 13 over the square root of 12 squared plus minus 5 squared. But minus 5 squared is the same as 5 squared. So it's 12 squared plus 5 squared. That's what they're working out. That's what they're solving now, you know. That is what you're solving. And this under here is a 5. This under here is a 13. Look at it carefully. Right? So, let me mark it. This under here is a 5. All of this works out to be 5. This under here works out to be 13. So I can cross multiply this 13 over here, and cross multiply this 5 over there. All right, let's see what we get when we do that cross multiply. So I'm gonna get 13 times this. Equals, I'm gonna get 5 times that. Remember, it's plus or minus. Plus or minus 5 times the 12x minus 5y plus 13. And then I'm solving. I'm solving now. Right? I'm solving now. So I'm going to expand this side and expand that side. So 13 times 3 is 39. So I'm getting 39x. 13 times 4 is 52. I'm getting 52y. 13 times 5 is 65. So I'm getting plus 65. Equals plus or minus. I'm going to multiply the 5 inside here now. 5 times the 12 is 60. So I'm going to get 60x Then 5 times 5 is 25. So I'm going to get minus 25y. 5 times 13 again is 65. I'm going to get plus 65. They're going to work one with the plus and one with the minus. So let me take over the same equation, one with the plus and one with the minus. I'm just copy it down there. One with the plus and one with the minus. Copy, paste. Let's say I'm working with a plus. If I'm working with a plus, I don't need these brackets. If I'm working with a plus, I'm write the 65 better. So you find that the 65s cancel. And if you consolidate the values, you're gonna get this in terms of the x values. In terms of the x values, all right. So in terms of the x values, it's 39 minus 60. So that's minus 21x. So that the y value is 25 minus 25, come add to that. Give me 77y. So 77y equals 0. And this now can be divided through by what? 7. Can divide this through by 7. So divide this by 7, we get 11y. Divide this by 7, we get minus 3x equals 0. That's one of the lines. All right, that's one line. This is one answer. The other line now is with this minus. We're going to use a minus. Here's when we use a plus, right? Here's when we use a plus a while ago. But now we're going to use a minus. So I'm going to come about the same equation, and I'm going to use a minus. So this is the OR situation now. This is OR. I'm going to use a minus. I'm going to take this off and use a minus on it. And then working this out. So it's 39x plus 52y plus 65. Apply this minus across here now. We get equals minus 60x plus 25y minus 65. All right, and then we're going to consolidate the values now. So I'm going to take this minus 60 and add to that. Get 99x. I'm going to take this 25y and subtract from 52. 52 minus 25 is 27. I'm going to take this minus 30, minus 65 and add to that 65, get 130 equals 0. So this is my second line. So those are the two locus, or loci. 1, 2. Two possible lines.
Okay.
Yes?
You can explain again why you would have the plus or minus.
Explain why we have a plus or minus again. All right.
Yes.
All right. So look. If you have two lines, right? One running so and one running so. Right? I want a point that is equidistant from the two lines. My point can be here. This distance, this distance. That's where my point can be. So my point is always here. I'm going to end up on this line. That's one possible line, don't it? One possible line will be this. That line is equidistant from the two lines. But my point can also be over here. It's in purple. Instead, equidistant from this and from that. Or it could be here, 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 or here, or here, or here. And so there's a second possibility, a line that runs here. You get me? So how the plus or minus come in now? Don't put the point here. So let's say I'm using a point on this, and the red one is for a point on this. In the case of it considering this line from these 2 points, there are 2 possibilities. From this one line first, then this side would take care of maybe for the plus, and this side, the point can be on this side, will take care of the minus. That's why we put plus or minus to account for the point that the point can be on either side of the line. You understand?
Yes, sir. Yes, sir.
Good. That is why. Remember, you know, instead of being there and there, relative to this line now, because this point could instead be somewhere over here, like over there. So relative to this line now, the same thing. You have to take the positive or negative to account for the fact that a distance can be here or there. Because the point can be here or here as well. So you have to put this might be a plus and this might be a minus. So you just need to introduce one plus or minus in the expression. So I introduce my plus or minus here. Here. The distance from one of the line is plus or minus the distance from the other line. Plus is the plus and the minus is for the point being on either side of the line. So if it's on one side of the line, plus will take care of that. If it's on the other side of the line, the minus will take care of that. So this covers the 2 possibilities. And I just show you on the sketch that is 2 possible lines. The line that you want, as is equidistant between those 2 lines, is either it runs down here, or the line runs down here. One of these 2 lines you want. You get me?
Yes, sir. Yes, sir.
All right. And the plus or minus is what I'll count for the 2 lines. Plus or minus. Because remember, as I said, the plus is for the point being on one side of the line. The minus is for it being on the other side of the line. And that is it. As I said, I don't see any question in CXC that asks for no question that requires the use of this formula that we did in this question. The distance from a point to a line formula. All the lines that are given CXC is always a vertical line or horizontal line. All right, but we this question now, number 5. So P is a constant distance of 2 units from that point, from that point. Well, this one easy, you know, guys. This is almost like common sense, you know. So if you have a fixed point, 3, 5, I don't have to work out this one. All right? And you have a point that is a fixed distance of 2 units from it. And that point must be in a circle of radius 2 units with this as a center. If you call this point xy, that means that this distance is always 2. Right? So the distance between this and this is always 2. So you get x minus 3 squared plus y minus 5 squared. Square root of that is the length of that line now. That is always equal to 2. I square both sides, I get x minus 3 squared plus y minus 5 squared equals 2 squared. See? That's the equation of a circle where the center is 3, 5 and the radius is 2. Then you have to work it out. So distance from a fixed point always is the equation of a circle, where the fixed point is the center and the distance is the radius. So you literally can write it down like that and get it. That one is always the easiest one that is clearly a circle. Want to go to that?
Yes, sir. Yes, sir.
All right. So let's move on. Number 6. Trying through these fast, man. I'm going to do some past papers after this. There are about 4 past papers. That one, no. P is a constant distance of 5 units from that line. That's a line 1 again. P is a constant distance of 5 units from that line. All right, so to give us that line, which is 4x minus 3y equals 1. I'm going to transpose the 1 and get 4x minus 3y minus 1 equals 0. The distance of P from this line is always 5 units. So it means that that distance from P, remember P is a point xy now. So like you're writing back the equation, the distance becomes the equation, and dropping the x value for the x right here, which is x, still x, right? It's still x, minus 3 times, you put the y value at the point here, beside the 3, but still y is a y value, minus 1, over the square root of this value squared plus this value squared, 4 squared plus 3 squared, and that is a constant value of 5, but it can be plus or minus 5. Because it can be up the line like this, and the 5 is either below the line, like that. But the line might be like this, and the 5 can be this distance, or it can be this distance, 5 or 5. So the line that you want is either below it or above it. So it's 2 lines you're gonna get. You get the 2 lines by putting the plus or minus. The plus or the minus right here. This one here says a 5, guys. Square root of 4 squared plus 3 squared is 5. This works out to be 5 under here. We multiply the 5 across and get 25. So I'm gonna get 4x minus 3y minus 1 equals plus or minus 25. I'm gonna get 2 equations, one with the plus and one with the minus. All right, so with the plus, 4x minus 3y minus 1 equals 25, or make that smaller. Or I'm going to get 4x minus 3y minus 1 equals negative 25. 2 lines. So if I consolidate this, bring over the 5, I'm going to get 4x minus 3y, 4x minus 3y minus 26 equals 0. Or bring over this, I'm going to get 4x minus 3y. It's going to become plus 24. And it kind of makes sense. Because if you have a line, right? And you want another point, you want a point that is equal, the same distance from the line. They must run parallel to it, above or below it. That's why the 3 lines start out like this. This value represents where the intersect the y-axis intercept. This has to do with the y-axis intercept. This has to do with the y-axis intercept. And on the equation, this has to do with the y-axis intercept. Right? That's all I know. But the rest of the lines is the same. Why? Because the 3 lines parallel. The original line and the 2 locus lines parallel. That's why the equation is coming out like that. Make sense? Make sense, guys?
Yes, sir.
Yes.
All right. So these are the answers. These are the answers. These are the 2 lines right here. This one or that one. All right. Easy stuff. Easy stuff. All right. Let us do the last one on the sheet and then jump to some past papers. This one. All right. So this one says, A is the point minus 1, 0. B is a point 1, 0. And the angle APB is a right angle. Once you see right angle, guy, you know you're going to use gradient. You're not going to use the product of gradient equal negative 1. You're going to use gradient perpendicular. So let's sketch it. Once you bring in angles, you know so you're going to use gradient, especially right angles, right? So I'm going to sketch this one now. So sketch it as they gave us. So it's like we have y-axis, x-axis. One point is negative 1, 0. Over here, this is A. negative 1, 0. Let's put it here. A is a point negative 1, 0. And B is 1, 0. Same distance over this side. 1, 0 over here. That is B. It is 1, 0. And they said that the angle APB is 90. So if I were to draw it, make it 90. So it's like, me draw this. This angle is 90. I'm going to put in my point P right here, XY. I'm going to see this, you know, this is going to be a circle. It's going to be in a circle around this, you know. Going to be a circle around this, like that. That's what you're going to get. You know what this is? This is like a diameter. Angle subtended by a diameter. The circumference is 90 degrees. So it's going to be a circle like this, where AB is a diameter. That's what it's going to be. I look at it, I see it. We can work it out. Because it means that this gradient and this gradient, we multiply them and get negative 1. So that's what we're going to use for this one now. Because the angle inside this is 90. So it means that the gradient of AP times the gradient of BP is equal to negative 1. If this angle is 90, then this gradient and this gradient, they are perpendicular gradients. When the gradients are perpendicular gradients, the product of perpendicular gradients is negative 1. That's what they're going to do. What's the gradient of this line? Difference in y by difference in x. It's y minus 0 over x minus a negative 1 becomes x plus 1. That's that gradient. Times, what is this gradient now? This one. It will be again y minus 0 over x minus 1. That's a bit of gradient. That all equal to negative 1. First, the gradient is equal to negative 1. That's what you're solving. That's a locus. It's a locus, you know. On here, we're going to get y squared. It's times, you know, we're going to get y squared. We're going to get y squared over, this becomes the difference of two squares, which becomes x squared minus 1. That is equal to negative 1. Multiply this over here, we get y squared equals minus x squared plus 1. Transpose this, we get x squared plus y squared equals 1. See, that's a circle, you know. It's a circle center at the origin and the radius of 1. That's what I said we would get. A circle like this. Right in purple. But this and this distance is the same from this axis. You get a circle like that. Center is the origin and the radius is 1. This is also 1. That's what we're gonna get. That's it. Any questions on that? Any questions on that?
Loci.
All right. So time for past papers. This is a short session. Just one simple, easy topic. Let's look at, there's a question on 2014. I was searching for them before the class. They don't come on every exam paper, you know, nothing can come on every exam paper, nothing. No topic can come on every exam paper. So there's one on 2022. Let's look for it, 2022. Remember guys, just make a sketch. See here, look at this one. See here now. It's a locus question, you know. So you see, it's part of 6 marks for it, you know, 6 marks. So you want that 6 marks. 6 out of 25, that's a lot. And this question 4, Question 4 has 4 parts. So part A is one question. Part D is a different question, vectors. Part C is a different question, vectors again. And then part D is a locus. Question says the point PXY moves such in the XY plane such that it is the same distance from this point as it is from this line. Determine the locus of P. So I'll just sketch it. Easy question. Sketch it. Sketch it so you can see what is happening. So when we make a little sketch, everything is to the right based on this, because that's in the positive quadrant, first quadrant, and that's also on the right side. This is my y-axis, this is my x-axis. I put in the line x equals 3 first, right here. So let's say that this is my line x equals 3. I'll put on this point 1, 2. So 1, 2 is maybe here. 1, 2, A. Let's say that this is A, 1, 2. I'm going to put on my locus now. Let's put down in purple. And it's the same distance, right? Same distance. Remember, the distance from this line is a perpendicular distance, guys. So I put a point here. So that this perpendicular distance is the same as this distance. This distance and this distance is the same. All right, that's why I put these marks on it. This line means that this line is the same length. Let me zoom it up now. All right, for ease of reference, I'm going to call this point over here so B. And put on the coordinates on it. Remember, this is my locus point, P. Put on back in purple. P is X, Y. So this point and this point have the same Y value. So this now point is where X equals 3. So I can put my 3 down here, so. Right here says 3. So this point B must have X value of 3 and a Y value. Hold on. And a Y value the same as this point. So the point is therefore 3Y. And then what is this length? We're gonna need that length, It becomes 3 minus X. Because the X value at this point is 3, is X, sorry. So this length is 3 minus X. Right? So distance from the line is 3 minus X. I put on in green or in black. This length is 3 minus X. That's this length. It's 3 minus X. And then this length now, we're going to use the length of line formula to these 2 points to get it. And put it equal to 3 minus X. That's what we're going to do. So we're going to say AP equals BP to proceed. AP equals BP. Let's use the blue and the lower. I'm going to say AP equals BP. So AP equals BP. If you want, you can square it so you don't have to put the square root. All right? AP equals BP. What is AP? This length. Length of line formula is the square root. Difference in the X value squared. X minus 1 squared. X minus 1 squared. Plus difference in the Y value squared. Y minus 2. Y minus 2 squared. That's the length of AP equals BP. BP is just 3 minus X equals 3 minus X. That's what you're solving. That's a locus, You normally square, expand, and simplify. You want to square both sides first and get X minus R. You can square both sides and just expand this under your same time. So I'm going to expand this. Now, I'm going to square both sides first. So I'm going to write it back and just square both sides first. So the whole work is there. So when I square both sides, this square root sign gone, and this side becomes a square. When I square both sides. And so now I'm just simplifying that. That's my locus. I just need to simplify it. So this expand this first. I get x squared minus 2x plus 1. Expand this. I get plus y squared minus 4y plus 4 equals, expand here now, I get 9 minus 6x plus x squared. And the x squared is going to cancel each other. This x squared will eliminate this x squared. All right, and let's consolidate the other ones. So this y squared is the only y squared in there. So I'm going to have y squared. Then the x values now. This minus 6x, the x value, sorry. That I put on the y value first. This y value is the only y value in there, which is minus 4y. X values now. This minus 6, come over and add to that. So it becomes 6x minus 2x is plus 4x. Wait, plus 4x. That takes care of my x. Now I need to take care of the values now. So this is 1 and 4 make 5. 5 cancel 5 out of this limit 4. I can put another way. This becomes 5 minus 9. We care over the 9. 5 minus 9 is negative 4. What is minus 4 equals 0. That's the locus of my answer. This is 0. That's it. Sketch is very helpful, guys. Can you see exactly what you're doing? But I go to that.
Yes, sir.
All right. Screenshot. So, and if you screenshot the question, see it there, and do it over. Let me delete this first. And screenshot the question. See there, screenshot the question. So you can do it over by yourself. And put by the solutions now. You can screenshot that as well. Try and do it by yourself first before you look back at the solutions. And you can look back at, you can use the video. I'm going to share the video and you watch the video. The past paper questions, 2022. Alright. The time before that, the set one was actually 2016. I can recall, right? Maybe there are others, but 2016. Maybe let's also set some on the paper 3. But let's do and also on the multiple choice. You can get locus question and multiple choice as well. Alright. So 2016 was the next one. Let's see. 2016. Alright, so locus question again. 2016 paper number 4, gel the question 4, part of question 4. Right, number 4. This one is the last part of question 4. Alright, here, how much marks for it this time? 5 marks this time. 5 marks for it. Right here. We want the 5 marks. We want it. Alright, 5 marks. Alright, let's see. The point PXY moves such that its distance from the x-axis is half its distance from the origin. The point moves such that its distance from the x-axis is half its distance from the origin. Sketch it. Sketch what they have said. That's all you have to do. So I'm going to sketch it right here. When you sketch it, it becomes easy. All right? Its distance from the x-axis is half its distance from the origin. All right? So I know that the origin comes into play. Put down in red. And in this question, it looks like I'll have to place the point. So let's place the point here first, P, and give it coordinates x, y. Now, this is O, the origin. Y-axis, x-axis. And the question is referencing these two distances. Drop them on in purple. This distance, to the origin, I'll put them on in black. Put them on in black. This distance to the origin. And this distance, the x-axis. What is it? Move such that its distance from the x-axis is half its distance from the origin. So let's leave the points. Let's leave the point. This is P already. This is O, origin O. This is the origin O. Let's call it O. Origin O. Let's call this point here. So let's just call a point A. Let's just call this point A right here on the x-axis A. What will be the coordinates of A? A will be the point x0, kind of the same x value as this. If this point is xy, the x value at A is x. The question basically says that, let's put down in words now. The distance, let's do it again, move such that the distance from the x-axis, distance from the x-axis is this one. And you know what that distance is? That distance is y. Up here says y now. That distance is y. And you know this distance already. That distance, because this is 0, 0, then this distance right here becomes the square root of x squared plus y squared, you know, that distance. Because like here says x, and here says y, so it becomes the hypotenuse in that right angle triangle. Anyway, you want to look at it. Now what them say now, let's put in what them say. Them say the distance from the x-axis, which is AP, is half the distance from the origin. Distance from the origin is OP. That's what they have said. You know? Distance AP is just y. Is half the distance from the origin is this. Square root of x squared plus y squared. That is the locus. You know? You multiply 2 by 2 first and get 2y equals the square root of x squared plus y squared. You can square both sides and get 4y squared equals x squared plus y squared. And you can transpose this y squared and get 3y squared equals x squared. That's the locus. Done. And if you want, you can write, transpose this over here and get x squared minus 3y squared. I'll put it that way. Y squared, 3y squared minus x squared. 3y squared minus x squared equals 0. This is the answer. If you left this, good to go, same way. But that is it. So you put what they have said on a sketch and show what they have said on a sketch, and then you transfer that sketch now to the equation in terms of what they have said.
So why is the length of PY?
Why the length of what?
PY.
Why is this length y?
Yes, sir.
All right, let me ask you a question now. If we have a point here, 3, 4, what is this length on the x-axis? This point is 3, 4. What is this length from the x-axis? Answer now? 4. This point is xy. So it's x this way and y that way. But the point is xy. See that?
Yes, sir.
Good. Let's put another way again. So if I just show the point P then alone, here, by itself, pxy, then this length is x, and this length is y. Because that's how we get to the point pxy. X across here and y up there. You good now?
Yes, sir.
All right, good. Anybody else have any question?
Sir, how you did get the length of the
Ah?
hypotenuse? How you did get the length of the hypotenuse?
This length here, sir?
Yes, sir.
You can do it by using these 2 points. So like you're doing the distance between the point 0, 0 and the point xy.
Alright.
So it becomes the square root of x minus 0 squared plus y minus 0 squared. But generally speaking, you want the distance from origin to a point. So for example, if I give you the same sketch a while ago, and I put a point 3, 4 right here, so it means that I have a triangle 3 out here, 4 up here. This is 3, this is 4. So if I want this length, I have a right angle triangle. Pythagoras' theorem, this length becomes the square root of this side squared, which is actually this coordinate squared, plus this side squared, which is actually this coordinate squared. That's the same thing I did here. You good now? Not x. I want to put that 3 right here. You okay now? First, we'll ask a question.
Yes, sir.
Who is that? Antoine?
Yes, sir.
All right. All right, so everybody good with this? I can move on. It's a matter of interpreting what they have said, put it on a sketch, and then you write what they have said mathematically as an expression like this, and then you proceed. Most times these questions have to do with distance, length. Most times, that's what the questions are set up. Most times. They're very easy. All right. So we'll finish 2 of them. Only 2 more we have to do now, guys. This and the past papers, and only 2 more.
You can rub
All
off.
right.
You can rub off.
All right. Clear it so you can screenshot. Good. Clear it so you can screenshot. All right. Screenshot that. I'm going to put it back now and screenshot that as well. So you can try and work it out yourself. All right. Let's continue and look at this one on 2015. So they gave 3 consecutive years, 14, 15, and 16. And I think that maybe there's one in there that I'm not finding, but there's one on 2015. Let's find that one, 2015. And there's also one on 2014. They didn't set any on 2013. I remember that clearly. I was looking for it. 2013 was the first year the exam came, the new syllabus, when I put locus on the syllabus, and I was looking for it. And I didn't set any because I taught my students it, and none came. But then it came in 2014. And a lot of people came out of the exam and said, "What is locus? They never heard about that yet." So it means that at that time, a lot of teachers didn't teach it. But I taught it. My students crushed it. Yep. All right. So this is 2015 now. This is 2015. Right here. All right. So look at it. Make a sketch and put what they have said. Put mathematics on what they have said. So this one says the point xy moves so that its distance from a fixed point O is 2 times the distance from a fixed point this. Simple. The distance from this is 2 times. I'm telling you, is mean equal. 2 times the distance from this one. So let's call this point P. Let me call this point A so we can reference them. Call this point A. I don't have to sketch this one now. Can I say this point? Call this point A. And call this point B. So this distance is AP. So basically what I've said is that this distance AP, let's put on in blue, AP is 2 times the distance from this point. So this distance now is BP. It's 2 times BP. That's what you're solving. AP is 2 times BP. That's what you're solving. So the distance between these 2 points is AP. That becomes the square root. Difference in x value square root is x minus 0 squared plus the difference in the y value squared, which is y minus 3 squared. That is equal to 2 times the distance BP now. So BP now is the distance between these 2 points. I'm doing 2 times that. So you're going to get the square root, difference in x value squared, x minus 5 squared plus y minus 2 squared. That's it. That's what they're solving. That's what they're working out. Square both sides first. Get rid of the square root sign. Square both sides. If I take out the square root, in fact, let me leave it. I'm going to take out the square root, and it's going to become a 4 when I square both sides, right? If I expand under here, I'm just going to get x squared for this one. X squared. Oh, you know, I remember this paper. Them say show that the equation of a locus is a circle. To show it's a circle, guys, you're going to get an equation with x squared plus y squared in it. Equals something. Once you get an equation like this, x squared plus y squared, it's a circle. So all you need to do, you know, get an equation in a general form of an equation. X squared plus y squared equal anything. Becomes a circle. All right? So that's what we need to do. Remember my student who placed in the Caribbean that year. He did too much work on this question. Still got it right, you know, but you know, it was actually for 12 marks. See, got it, you know, so 12 marks. And he did too much work on it because what he did, instead of just leaving it like this, he carried it down to x minus a squared plus y minus b squared equals r squared. Spent a lot of time doing it when all he had to do was leave it like that. The general form, because the equation of a circle in the standard form is this, but in the general form is that. You got it in the general form and felt that you had to put it in the standard form. But I told him after the exam that the general form was fine. But he's still placed in the Caribbean that year in pyramids. And he was in 5th form when he did. When he placed in Caribbean. Right? Name is Ferguson. Anyway, let's continue. So square both sides here. This under here is going to become an x squared alone. This one under here is going to become a y squared minus 6y plus 9 equals, when I square both sides, it becomes a 4 into, I'm going to square this under here, expand it now, I'm going to get x squared minus 10x plus 25 and squared. This as again, I'm going to get plus y squared minus 4y plus 4. That's what we're going to get, right? I'll leave the A and the B. And this has to be simplified down. Don't want a space to work it, but let's see. I don't need this. And so this becomes 4 times everything, right? Because this becomes 4 times everything. Remember now, I'm going to transpose the rest of them over here. So I'm going to get 0 equals 4x squared minus x squared is 3x squared. And then 4y squared minus x squared is also 3x squared. So I've dealt with these. I dealt with x squared.
3y squared.
Y, thank you very much. 3y squared. Sharp I Washington. All right. Then we're going to deal with the x values now. So this is 4 times negative 10, that's negative 40. Negative 40 minus another 1 makes negative 41. So I'm going to get minus 41x. Minus 41x. And then I'm going to deal with the y's now. So this is 4 times 4, that's 16, negative 16. And then this what comes over becomes a plus 6. So negative 16 plus 6 makes negative 10. So I'm going to get minus 10y. Look at the numbers now. This is 4 times 25, that's 100, and 4 times 4 is 16, so it's 116 that. That's 116, and then I'm going to subtract this 9. 116 minus 9 make how much? 60 minus 9 is how much? 107, don't it? That's the equation, you know. To make it have an equation of a form, x squared plus y squared plus something else equals 0, like a circle. That's going to divide through by 3. So if I divide through by 3, then I'm gonna get x squared plus y squared minus 41 over 3x minus 10 over 3y plus 107 over 3 equals 0. This is the equation of a circle. So they say show that the equation of locus is a circle, i.e. a circle. They never ever given a property of a circle at the center of the radius, but once you get to the equation like this, x squared plus y squared, x value, y value, and all of that, that's the equation of a circle. Don't need to know the center point of the radius or not like that. Just need to show that this is a general equation of a circle. General form for the equation of a circle. That's it. Are you good with that?
Yes, sir.
Yes.
All right, so let me clear it now. Let's take a screenshot. They can work it over for me. Take a screenshot of it. And put it back now. Screenshot that as well. So he did too much work. Even though it was 12 marks, feels like a lot of work, but I would stop here. I was telling that that's a general form for the equation of a circle. Because they say show that the equation of a locus is a circle. This is a circle. It's a general form for a circle. I don't have to go any further. And they gave 12 marks for it. So I think maybe they actually wanted persons to go down and put it in the standard form, but nope. General form is good. That's the equation of a circle right there. All right. And then now there's one in 2015, 2014. 24, I think 2014 is straightforward one though. Like distance from a point. There's a certain distance. 2014. I think that one is a straightforward one. Where is it? Right here. Right here. That's a locus question. A point P moves in the xy plane such that its distance from this point is always root 2. Let's work that out. It's like they call a point P xy. The distance between these two values is equal to root 2. So I get an equation something like this. I would say the square root distance square root of x minus 2 squared plus y minus 3 squared is always equal to root 2. Square both sides, I get x minus 2 squared plus y minus 3 squared equals 2. Done. That's the equation of the locus. It's a circle with the center point this, and the radius is root 2. So this is like having root 2 squared, and the radius is root 2. All right, that's it. This equals 2. That's it, guys. This one is the easiest one of them all. So don't call any other one on any past paper. I think I gave you all of them that I've ever said. Yeah, I think I gave you all of them that they have ever said. I think there's one. Oh, we did one already from a line, right? Let's recap. We did one from a vertical. I think there was one from a vertical line. I just want to make sure I gave you all the ones that they have ever said. Just want to make sure that one in 2016, that one, and then 2022. Right, from this vertical line. Right here. This is the only time I set one line distance from a vertical line. Right here. Alright, so I give you all of them that they have ever set. 4 since they start the syllabus. There was none last year, I checked. There was none on last year's paper. So you can look out for it this year. That's it now, guys. That's it for today. You know what to do. You know what to do. You need to redo the questions. I'm going to send the video and you use the video to help where necessary. All right? And you see that what the approach is for all the questions. Make a sketch, guys. Make a sketch. And try to implant information in a sketch. Try to work in the positive quadrant. Put the point P in the positive quadrant where you're making a sketch as much as possible. Unless they say something specific. But generally speaking, they won't say anything specific. So always set it up, your sketch, so that the XY is in the positive quadrant and work from that. All right? That's like a tip to make sure you get it right. Okay, everybody?
Yes, sir.
Yes.
All right, I'm going to end it now. Work on that for me,
All right,
please.
sir.
All right, cool.
Later,
Bye,
sir.
everybody. Yeah, man, cool.
I see.
Bye-bye.